Dear learners, happy to see you all again. In this session, you will learn how to handle exceptions in your Python programs using try, except and finally statements. This module will encourage you to write clean, readable and efficient code in Python. Till now, we have explored basic Python. If you are new to a programming language, then you might have faced a lot of hurdles during programming till now. The hurdles may be generated due to errors. A Python program terminates as soon as it encounters an error. In Python, an error can be a syntax error or an exception. In this module, we will discuss what an exception is, how it differs from a syntax error. First, let us try to understand the difference between an exception and a syntax error. Syntax errors occur when the parser deducts an incorrect statement. Observe the example on the console. Here we have a print statement wherein opening parenthesis is missing, and in the next print statement a double quote is missing, closing quote is missing. When you run these two lines, see what error you are getting. In the example seen, there was an extra bracket and a missing quotes. These are syntax error. What is a syntax error? A syntax error is an error in the syntax of programming language. That is, the errors caused by not following the proper structure of the language are called syntax or parsing errors. Syntax error is caught by the compiler or interpreter, and we have to fix them for correct execution of the program. Now, you remove the errors and run the code again, you will get the output, right? Okay. Coming to exception. What is an exception? Try running the Python statement on the console in your interpreter. Here we have a print statement which divides the value of 10 by 0. When you run the statement, see what you are getting. In the statement, just you tried. Did you find any syntax error? Of course, no syntax error. Syntactically a correct statement. But what did you get? This time we ran into an exception error. This type of error occurs whenever syntactically correct statement results into an error. The last line of the message from the Python interpreter tells what type of exception error you got. Instead of showing the message as an exception error, Python gives the details of what type of exception error was there. In our example, it is zero division error. Python has various built-in exceptions, and also let us create user defined exception. We will discuss them later in this module. So, what is an exception? An exception is defined as a condition that causes an abnormal termination of the program. Therefore, whenever an exception occurs, the program halts the execution and thus the further code is not executed. Therefore, an exception is the error which Python script is unable to handle. So, for the gradual termination of the program, we need to handle the exception. Python provides a way to handle the exception so that the other part of the code can be executed without any disruption. But if you do not handle the exception, the interpreter does not execute all the code that exists after that. Shall we try one more example for an exception? Watch the code over the screen and also see the output. Here we have a list having 3 elements. In the first print statement, we are printing the second element, that is the element having the index 1. In the second print statement, we are trying to print the element having the index 3, that is the fourth element, but the list has only 3 elements. So, when we run the script, see what exception you are getting. Syntactically, there is no error in the script. The element in the second index is accessible, but when we try to access the fourth array element having the index 3, which is out of bound of the list, an exception called index error is raised. Even though the last statement, that is the statement which prints the first element, is correct, it was not executed. This is because once the exception has occurred, the execution of the program has been stopped abruptly. Hope you understood what an exception is and how it differs from an error. Having seen how an exception occurs, let us see how to handle it. If we do not handle exception, it will lead abrupt termination of a program. So, for gradual shutdown of a program, we need to take care of and handle exception. So, exception handling is an appropriate method for handling the errors and special conditions in a program. When you think that you have a code which can produce an error, then you can use exception handling. So, if you have a doubt that some of the statements in your script may raise an exception, you can defend your program by placing the suspicious code in a try block. After the try block, put an except statement followed by a block of code which handles the problem gracefully. Have a look on the screen for the syntax of using try and catch. Here you can see how to define exception handling in Python. You have a try block, you put the codes which may raise exception inside the try block, followed that you have an except block wherein you can handle the exception. As you have seen, exceptions are handled using a try statement. A suspicious code which can raise exception is placed inside the try class, and the code that handles the exception is written in except class. It is you to decide what operations to be performed once we catch the exception. Here is a simple example. Have a glance over the console. Here we have a statement which divides 10 by 0, which may cause an exception. So, we put them it inside the try block, and following the try block we have an except block which handle the exception. See the output when you run the script. So, in this example we put the suspicious statements, that is the statement which may cause problem inside a try block. In our case, it is a statement that divides 10 by 0 and prints the result. This statement throws an exception. So, we have an except block that catches the exception and handles it. This leads to grace closing of the program. Just recollect what was the output when we run the same code without handling the exception. Shall we rewrite the example which generated index out of range exception using exception handling? Try what you see on the screen. Now, we have put the statement which we suspect that it will raise an exception inside the try block. Following that, we have an exception block to handle this exception. Just compare this result with the results what you have written without using exception handling. Diagrammatically, the exception handling can be represented as you are seeing now. So, we have a try statement, following that block of statements which may cause an exception. Following the try block, we have an except block inside the except block we have code which will handle the exception, right. I believe that by now you would have definitely understood the need for handling the exception. In the previous examples, we did not mention any exception in the exception class. This is not a good programming practice, as it will catch all the exceptions and handle every case in the same way. We can specify which exceptions an except class will catch and handle it differently from others. In order to do so, Python provides several built-in exceptions. A table which lists the set of built-in exceptions supported in Python can be seen over the console. Here you can see the list of exceptions and the reasons why these exceptions occur. Again a set of exceptions along with cause for exception. Let us write a few examples to realize when some of the built-in exceptions are raised. First, we will write a script that tries to access the array element whose index is out of bound and handle the corresponding exception. Similar example what we had written earlier, but instead of simply writing the except block without mentioning any exception, here we mention the exception name as index error. Run and see what output you are getting. Now let us see how to exercise arithmetic error exception. So here again we divide 10 by 0. So this is an arithmetic error exception. So we put that exception class instead of simply writing except. In the program we saw just now, a number is being divided by 0, which will raise an arithmetic error exception. Arithmetic error is the base class for all arithmetic exceptions which are raised for errors in arithmetic operations such as overflow error, division 0 error and floating point error. As 0 division error is the class derived from arithmetic error class, instead of arithmetic error we can also mention 0 division error as the arithmetic expression involves division by 0. Just do by yourself. Okay. Next, let us go to import error. Import error occurs when you try to import a module which does not exist. When you made a mistake while typing or the module does not exist in the standard path, the import error may occur. Let us attempt to see how it occurs. Here we are trying to import a module named request. When you run this, you can see an exception called no module named request. Here again we see one more import error example. When I import datetype, it says that no module found. As there is no time.py is found in the datetime module, it causes an import error which is gracefully handled in the except block. Now let us move on to keyboard interrupt. The keyboard interrupt exception is raised when we try to stop running a program by pressing Ctrl C while giving the input. Consider the script over the console. So when you run the script, it will expect you to enter the name. After entering the name, before entering the age, if we press Ctrl C, keyboard interrupt rises. When the same code is rewritten to handle the exception, see what you are getting. When you run the same program again and when you press Ctrl C before entering the age, the exception is handled and program is terminated gradually. Then what is next? Next comes the key error. What is it? The key error is raised when you try to access a key which is not in the dictionary. This means the key does not exist. Shall we try a script to demonstrate the key error? So, here we have a dictionary MyDict having 3 keys 1, 2 and 3, but the print statement tries to print with the key 5. So, when you run the script, it leads to key error. As such, key 1 exists, we got the values corresponding to the key, but the key 5 does not exist, an error generated, key error 5. So, how to deal with this key error exception so that the program does not crash even if key is not present? Now, notice the program on the screen. The same program is rewritten using try and except block. Now, when you run the script, the program terminates gradually by saying the key not exist. Let us do one more exception, value error exception. Your value error exception occurs when a function receives an argument that has right type but an appropriate value. Let us see an example. So, in this script, we are passing a negative number to the square root function. You cannot find square root for a negative number, so it leads to value error. If you put that statement inside the try block, the program terminates gradually. Slide 20. Now, you put the square root statement inside the try block following with an except class having the value error exception. When you run the script, the program stops gradually by raising the value error exception. Similarly, you can try other exceptions, right. So far, we have seen an except block with only one exception, but a try class can have any number of except classes to handle them differently, but only one will be executed in case an exception occurs. See the syntax for writing a try with multiple except classes. Let us work out one example script which can handle multiple exceptions. Here we have a list and the list items are divided by the number input by the user. These statements are put inside the try block. Following that, we have two except classes, one for handling index error and one for handling division error. For the input, when you enter 0, what happens? And the range is from 0 to 4, but we have only 0 to 3 elements in the list. Try running this program and see what you are getting. So, this is the output you will be getting if you input 0 for the input number, and when you try to access the element in the list which is not in its range. But remember that only one exception class will be executed in case an exception occurs when multiple exception classes are present in the script. If there are many statements in the try block which cause exception, the one which will cause the exception first alone will be handled. That is, the program control switches to except block, leaving the other statements to handle the appropriate exception block. Another point to be noted here is we can also use else in the exception handling. After all the exception classes, you can include an exception class. The code in the else block executes if the code in the try block does not raise an exception. Else class must follow all except classes. It is useful for code that must be executed if the try class does not raise an exception. Let us have an example for else class. So, in the previous example, we have added an else class. Try running the program and see the output what you are getting. A single try statement can have multiple except statements. This is useful when the try block contains statements that may throw different types of exceptions. You can also provide a generic except class which handles any exception. After the except classes, you can include an else class. The code in the else block executes if the code in the try block does not raise an exception. So, the else block is good place for the code that is not required to be placed in the try block. Next, we are going to have a glance on finally class in exception handling. The finally class is optional. It is meant for giving cleanup actions that must be executed under all circumstances. A finally class is always executed before leaving the try statement, whether an exception has occurred or not. Shall we see an example for using finally class? Have a look over the console. So, here we have included else class and also a finally class. Whether an exception rises or not, else class will be executed, but finally class will also be executed after executing or after handling the exception. Here again we have one more example to illustrate the use of finally class. So, what is the difference between else and finally classes? Else class will get executed only when no exception is raised by the statements inside the try block, but a finally block will be always executed irrespective of whether an exception is raised or not. Till now, we have been exploring the built-in functions provided by Python. However, sometimes we may need to raise exceptions manually instead of being raised automatically. Raise statements is used for raising an exception manually in Python. The syntax to use raise statement can be seen. So, the syntax for raising exception manually is keyword raise followed by the name of the exception class with an optional value. Here you can see an example of raising a value error if the age is less than 18. Having seen elaborately how to handle the exception in Python, let us now turn our attention to writing our own exception. In the previous example, we saw how to raise a built-in exception manually, which forces your program to output an error when something goes wrong. Nevertheless, sometimes you may be required to create custom exceptions that serve your purpose. In Python, users can define such exceptions by creating a new class. This exception class has to be derived from exception class either directly or indirectly. Most of the built-in exceptions which we have listed earlier are derived from this class only. Let us see an example. Here we have created our own class named myAgeException. Here again we have the same example, but this time when we raise an exception, we pass a string which is passed as an argument to the exception class, and that string gets displayed when an exception is raised. So, in the user defined exception examples, we create a class called myAgeException, which is a subclass of exception. We can then raise myAgeException in a raise statement and check for myAgeException in the except class. This new exception can be raised like other exception using the raise statement with an optional error message. In order to handle the error message, we define a constructor in the myAgeException class which takes the error message as argument. When the myAgeException is raised, the error message is passed to the constructor. The variable ageExcept is used to create an instance of the myAgeException class. Hope you are now clear the need for and how to handle exceptions. Okay. So, we have come to the end of this module. After having seen the differences between syntax errors and exceptions, we focused on various ways to raise, catch and handle exception in Python. So, here are the key takeaways from this module. Python facilitates us to specify the exception with except statement. We can declare multiple exceptions in Python classes since the try block may contain the statements which throw different types of exceptions. We can also mention an else block along with try except statement which will be executed if no exception is raised in the try block. The statements that do not throw the exception should be placed inside the else block. Finally, enables us to execute the code that should always run whether an exception is raised or not. Raise allows us to throw an exception at any time manually. In the try class, all statements are executed until an exception is encountered. See you again in another module. Have a good day. Thank you.